So if we're following along with the electrochem unit, we've taken a look at how to predict reactions. Now we're going to add to that, and we're going to predict redox reactions and then apply some stoichiometry. So let's take a look at that. So if you are not quite ready, you will need a data booklet and a calculator to do these questions. So when we're starting off, we're just doing what we did when we predicted reactions. You want to see what's present. So you have a solution. So you'd have water, potassium permanganate, an ionic compound that you can break apart. Acidified means hydrogen's present. And then tin 2 chloride is another ionic compound we can break apart. So when you're starting off with, just like when you're predicting, write down everything present. So we have water, potassium ions, permanganate ions. That's a 4. If it's acidified, you have hydrogen present, and tin 2 chloride, SN2 positive, and chlorine ions. Then using page 7 of your data booklet, you would identify all your OAs and your RAs. So going through, water is an OA and an RA, potassium is an OA, permanganate with the hydrogen ions is an OA. Tin is on both sides of the table, so it is both RA, and chlorine is, I believe, an OA. I need to double check that. It's an RA. Got that wrong. And now you want to pick your strongest. So the strongest OA will react with the strongest RA. So going through this, oxidizing agents undergo reduction. So we write down this reaction like you see it in the data booklet. So MnO4 negative plus 8 hydrogen ions plus 5 electrons gives you Mn2 positive plus 4 water molecules. And then your strongest RA, this undergoes oxidation. So you want to flip this reaction so that you also see tin 2 positive as a reactant. So tin 2 positive will give you SN4 positive plus 2 electrons. Then to add these two reactions together, we'll have to multiply the first half reaction by 2 and the second one by 5. So we'll have 2 MnO4 negative plus 16 hydrogens. The electrons would end up getting canceled. There'll be 10 on each side. So moving on to the second half reaction, S5SN2 positive. And then looking at my products, 2 Mn2 positive plus 8 H2O plus 5 SN4 positive. So just reiterating, you're distributing that 2 throughout the whole reaction, and then you're distributing the 5 throughout the whole reaction. So now we have our reaction. Your OA is above your RA, so you know this will be a spontaneous reaction. And now we can add the stoich to it. So from here, we have some information of potassium permanganate. So that would be the permanganate part of our reaction. So the volume is 14.3 milliliters. Your concentration is 0.0032 moles per liter. When we want to get to moles, we'll have to divide our volume by 1,000 so that we have liters. And then we find out that 25 mils of the acidic tin 2 chloride, so that is talking about the tin 2 positive, 25 mils, again dividing it by 1,000. And the question ultimately is asking for the concentration of tin 2 ions. So this is what we're solving for. So now that we have it lined up, the information about the permanganate will get you to moles. So we'll set that up. So 0.0143 liters times 0.0032 moles per liter. And that's of the MnO4. We'll get liters to cancel. Now we're at moles of our known, so we want to turn the moles of your known into moles of your unknown. So 5 moles of SN2 positive over 2 moles of MnO4 negative. So moles of MnO4 cancel, and now we're at moles of tin. And concentration when we're done is moles per liter. So now what we just have to do, we have moles in the numerator, we just need to see liters in the denominator, and there was 25 milliliters, which is 0.025 liters. So you can plug this into our calculator, and when you're done, you'll have the concentration of your tin 2 ions, and we should see 4.6 times 10 to the negative 3 moles per liter. If you found this helpful and would like to keep seeing videos, please, please, please subscribe. Also, let me know in the comments if you would like any other type of example, and I would love to do another one for you. Have a great day.